You are watching video on SEE Class 10 subject Science. In this video series, we are going to study chapters of Physics, Chemistry, Biology, Astronomy and Geology. Now this part deals with Physics chapter 4 and this is part 4 of the chapter. Now in this part, explanation of gravity or the weight is done. Now what we have noticed in nature is all objects fall towards the surface of the earth. All objects fall downward, or earth attracts all bodies towards its center. Now, this attraction force of the earth and bodies is called gravity. And this gravity is also known as weight of the body. Now, we are going to study this concept in this part. The definition of gravity: the force of attraction of the earth on a body lying on its surface or close to the surface of the earth is called gravity. Or another definition, another way, the force of attraction with which the earth pulls a body towards its center is called gravity of the earth. Now you see next definition, weight of a body. Weight of a body is gravity acting on the body. Now see the definition of weight. Weight of a body is gravity of the earth acting on a body, acting on this body. So weight of the body is same as gravity. Okay, this is the definition of weight. Now what we have understood here is weight of a body is similar, same as gravity of the earth acting on a body. Now this gravity is actually gravitational force. Okay, if it is gravitational force, then this is the formula to represent gravitational force, F equal to G m1 m2 divided by d square. Now what we understand from here is gravity of the earth acting on a body is gravitational force. Actually gravity is the special case of gravitational force. So how it is gravitational force? The first body is the earth with mass capital M, and second body is this man standing on the surface of the earth with mass small m. So there are two bodies, earth and this man. The mass of the earth is capital M and mass of this man is small m. And distance between their centers is taken as radius of the earth. Okay, distance between these two bodies, between the centers of these two bodies is radius. Okay, so actually this distance should come from right from the middle of this man, but this distance is very small, negligible distance. That is why radius of the earth is considered as distance between the centers of these two bodies. Okay, so there are two bodies and there is force between these two bodies, that is gravitational force. Okay, so this is the gravitational force and it is a special case of gravitational force because in this case among two bodies, one of the body is the planet earth. Okay, planet earth with mass capital M. That is why it is a gravitational force. Okay, and it is the gravitational force when one of the body is planet earth, right? So this is the special case of gravitational force. Gravity is the special case of gravitational force, and the earth is attracting this man towards itself, and this is gravity. Okay, there is a force between these two bodies. That force is actually gravity acting on this body man, and this is the gravitational force. Now we are going to see the next part, gravity or weight. Now we are going to explain it more. Okay, we are going to understand it more. Gravity is the special case of gravitational force. If it is a gravitational force, then its formula is F equal to G m1 m2 divided by d square. This is the formula given by Newton's universal law of gravitation. Okay, now I am going to write this formula according to the condition given here, right, from the figure. Now I'm going to write this formula, rewrite this formula from this figure. F is gravitational force between these two bodies, G is universal gravitational constant, capital M is mass of the earth, M, capital M, and small m is mass of this man, small m. Okay, two bodies, right? And distance between their centers is considered as radius of the earth. Okay, radius of the earth is distance between these two body. So this way F equal to G capital M small m divided by R square. The same formula is rewritten as this according to this condition. Okay, yes. And now see, this gravitational force can be written as weight because from definition what we have understood is this gravitational force or the gravity is same as the weight. Okay, so weight of a body is gravity acting on a body. So this force can be written as weight also from definition. So W weight equal to G mm divided by R square. Capital M earth, small m man, and radius is the distance between two bodies, right? So this is the formula. Now if W equal to gmm by r square, then we can rewrite it this way. W proportionality sign, by removing equal to sign and constant, we can replace equal to sign and this constant by writing proportionality sign. Okay, capital M small m divided by r square. Again rearranging this equation, W weight is directly proportional to mass and inversely proportional to the radius. Here small m is kept as constant for the time being. It is kept separately for some time, okay, to see the relation of weight with mass of the planet and radius of the planet. Small m is still there, but it is a constant physical quantity, so it is kept aside for some time. So weight is directly proportional to the mass of the planet, because capital M is mass of the planet, and inversely proportional to the radius of the planet, right? Thus what do we understand from here is weight of the body is directly proportional to the mass of the planet or the satellite. Weight of any body is directly proportional to the mass of the planet or the satellite on which this body is kept. Okay, so if the mass of the planet is more, then weight will be more. If mass is less, then weight will be less. Okay, we have to understand it this way. And again, next condition, weight is inversely proportional to the square of the radius of the planet or satellite. So weight is more when radius is small, radius of the planet is small, or when radius of the planet is more, then weight will be less, because it is inversely proportional, right? So we can understand these 2 points from this formula. Okay, weight of any body is more if mass of the planet or the satellite is more, and weight of this body is less when radius is more. Weight of the body is more when radius is less. Okay, so this relation we can understand from here, and this point is going to be more clear from this illustration. You see, mass of the moon is 7.2 into 10 to the power 22 kg. Mass of the earth is 6 into 10 to the power 24 kg. Jupiter mass 1.9 into 10 to the power 27 kg. Okay, radius is moon 1.7 into 10 to the power 6 meter, and radius of the earth is 6.4 into 10 to the power 6 meter. Jupiter 71 into 10 to the power 6 meter. So you can see the differences in mass and the radius in different planets and the satellite. These two are planets and moon is satellite. Okay, so how do these factors differ in the measurement of weight? We can see here W equal to mg. This is the formula to calculate weight. Okay, we are going to measure weight on the moon, we are going to measure weight on the earth, we are going to measure weight on the Jupiter, right? W equal to mg, W equal to mg, W equal to mg. Here supposing mass is taken as 1 kg, the mass is not going to change anywhere. It is a permanent physical quantity. Okay, so mass of a body is 1 kg here on the moon. Mass of the same body is 1 kg on the earth. Mass of the same body is 1 kg on the Jupiter. The mass of the same body is 1 kg, 1 kg, 1 kg in all these three conditions, right? So here we are going to measure the weight of the same body on moon, earth and the Jupiter. Moon, earth and the Jupiter, we are going to measure weight of the same body with mass 1 kg, right? So you see on the moon, W equal to mg, mass is 1 kg and the value of g is 1.67 meter per second square on the moon. Value of g is 9.8 meter per second square on the earth. Value of g is 25 meter per second square on the Jupiter, right? So finally calculation of weight is on the moon, W equal to 1.67 Newton, and on the earth it is 9.8 Newton, on the Jupiter 25 Newton. So you see the measurement of weight of the same body on Moon, Earth and the Jupiter are different. Yes, when you measure weight on the Moon of this body, 1.67 Newton. When you measure weight of this body on the Earth, 9.8 Newton. When you measure weight of this body on the Jupiter, 25 Newton. Now this difference in weight of the same body is due to mass and radius, value of mass and radius of Moon, Earth and the Jupiter, that we have understood. Okay, so this way mass of the planet, radius of the planet make difference in measurement of weight, because weight is directly proportional to mass of the planet and inversely proportional to the radius of the planet. Okay, so value of g, this is acceleration due to gravity, small g. We are going to study about this topic in the next part, right? So actually this small g is actually gravity. Okay, small g, this refers to gravity. Now the next part we are going to see is, you see, gravity of Jupiter is only 2.5 times greater than that of the Earth, whereas mass of the Jupiter is actually 390 times greater than that of the Earth. Okay, we are going to see these conditions. Mass of the Earth is 6 into 10 to the power 24 kg. Mass of the Jupiter is 1.9 into 10 to the power 27 kg. Here is 24, here is 27. Radius is 6.4 into 10 to the power 6 meter in Earth, and radius of the Jupiter is 71 into 10 to the power 6 meter. So okay, look at the differences here. Now mass of the Jupiter is 390 times greater than that of the Earth, right? So if you compare the mass, then mass of the Jupiter is 319 times greater. Now if this is the case, then gravitational force is directly proportional to the mass of the body. Okay, so the force, gravitational force, should be 319 times greater than that of the Earth, but it does not happen so. Okay, because you see radius of the Jupiter is 11 times greater than that of the Earth. We can see from this value here. Okay, so radius of the Earth, Jupiter, is 11 times greater than that of the Earth, and radius is inversely proportional to the force. Okay, so the gravitational force, or the value of gravity on the Jupiter is, of the Jupiter, is 319 times greater. It is not the 319 times greater than that of the Earth, because its radius is 11 times greater than that of the Earth. Okay, mass is 319 times greater, that is okay, but at the same time radius is 11 times greater than that of the Earth, and this value of radius 11 times greater, it will reduce the value of gravity on the Jupiter. Okay, so this way, because radius is inversely proportional to the force. Okay, if radius is more, then force will be less, right? So this makes the gravity of the Earth only, gravity of the Jupiter only 2.5 times greater than that of the Earth, although it has mass 319 times greater than that of the Earth, right? So if you see, this g represents gravity. Actually this g is actually acceleration due to gravity, but here we can understand this as gravity. Okay, so acceleration due to gravity on Jupiter is 25 meter per second square. Acceleration due to gravity on the Earth is 9.8 meter per second square. Okay, 25 meter per second square is about around 2.5 times greater than 9.8. Okay, so this is the reason. So gravity of the Jupiter is only 2.5 times greater than that of the Earth, right? So you see the mass of the Jupiter is 319 times greater, but it does not make the gravity 319 times greater, because its radius is again 11 times greater than that of the Earth, which reduces the value of gravity. Okay, now the next part is differences between gravitation and gravity. This is an important topic. Yes, what is the difference between gravitation and gravity? So in the previous beginning, we were discussing about this one. Gravity is the special case of gravitation. Gravity is actually gravitational force only. These two are same, but gravity, we can call it gravity in a special case. Okay, now we'll see the differences, gravitation and gravity. Gravitation is, it is the force between two bodies. right, in the universe, whereas gravity is the attraction force of the earth on a body lying on its surface or close to its surface. Yes, definition. Now here again, it is the universal force. Gravitational force or gravitation is universal anywhere in the universe. Okay, between the planets, between the satellite, between earth and the body, between moon and the body. Okay, so gravity is, it is not the universal force, because if there is force between Jupiter and the earth, then we do not call it gravity. Okay, we do not call it we do not call it gravity, it is only the gravitational force. Okay, that is why it is not the universal force, right? And you see, in gravitation it occurs between any two bodies in the universe. Okay, gravitational force is between any two bodies in the universe, between table and chair, between Jupiter and the sun, between moon and the Jupiter. So this is anywhere in the universe. Whereas gravity is, it occurs between a planet or the satellite and a body close to it or lying on the surface. In this special case only it is called gravity, otherwise it is not gravity. If it is between sun and the Jupiter, it is not gravity. Okay, it is only gravitational force. So these are the differences between gravitation and gravity. So with this we finish this part, and we are going to do acceleration due to gravity in the next part.